Hello all, welcome to my YouTube channel. Today we are going to do a hypothesis testing problem based on two samples. Okay, so let me read out the question first. The data from two fertilizer brands are summarized below. Brand A has sample size 10, mean yield 10, sample standard deviation 4.9. Brand B has sample size 10, mean yield 18.66 and sample standard deviation 4.64. The yields are assumed to follow normal distribution at 5% level of significance. Do the data provide sufficient evidence to conclude that part 1, two brands of fertilizers significantly differ. Part 2, mean yield of brand A is less than that of mean yield of brand B. Okay, so from the question we understand that we test for mean yield. Okay. So population mean, and there are two samples brand A and brand B. That means we are comparing means for two population, suppose mu1 and mu2. Okay, and also we can see that the sample sizes n1 and n2 are 10, both are 10 small samples. Okay, and also what is provided, sample means are provided 10 and 18.66 and sample standard deviations are provided, that is we know S1 and S2. So we can see that these are test for mean and also sample size is small and also sample standard deviations are given. Note that population standard deviation is not given, so we cannot use Z-test because the sample sizes are small and population standard deviation is not known. So we can use the small sample test for mean, that is t-test, and this will be t-test for two means. Okay, or t-test for two samples, whatever way you can say that. Okay, why we cannot use Z-test? Okay, this is test for mean. When we compare means, we can use Z-test, but there are two conditions. Sample sizes should be large, that means they both should be greater than 30, and population standard deviation sigma 1 and sigma 2 should be provided. Then we can use Z-test for two means. Okay. Now the next thing, that why we are doing hypothesis testing, what is the use of it? Okay, see, from the two samples we can see that mean yield of brand A is 10 and mean yield of brand B is 18.66. They are very much different. Then we can directly conclude that these two are very different. But why do we do hypothesis testing then? Okay, so why we are doing hypothesis testing? Because see the sample size, they are 10 very small samples, and on the basis of the sample observation, we cannot conclude about the population because they are very large. So there may be possibility that we are very much wrong. Whatever sample we have selected, there may be chance that this sample has given us this observation, but different sample may have given us different observation. That is why we do hypothesis testing, and on the hypothesis testing we conclude about the population based on the sample and also this 5% level of significance. What does that mean? That means that whatever conclusion we come about the population, whatever we conclude about the population, there we are not 100% sure. There may be 5% chance that we are wrong. So that is the meaning of hypothesis testing. Okay, so there are two parts of the question. We shall do the first part first. Okay, and we shall do the problem in both way. That is, first is conventional way. What is conventional way? In this method we shall find out the critical values based on the significance level and compare the critical value with the test statistic. And the second method is p-value approach, where we find out the p-value based on the test statistic value and then we compare the p-value with the level of significance. Okay, so let me start with the part 1 of the question with conventional method. Okay, so first step of null hypothesis testing is setting up the null and alternative hypothesis. So we can see that this is a test for two means. So null hypothesis will be based on the two means mu1 and mu2, and also we know that the null hypothesis is the hypothesis of no difference. That means in null hypothesis we say that there is no difference between the two population means. So we put the equality sign. Okay, there will be always the equality sign in null hypothesis. It may be equal sign, it may be greater than equal sign or less than equal sign based on the question. Okay. The alternative hypothesis is the opposite of null hypothesis, and it will be based on the question. Okay, what is the question in the part A? Two brands of fertilizer significantly differ. That means they are saying that whether the two brands are differ. That means mean yields differ from each other. It is not mentioned whether one is more, one is less. So when this type of question arises, we put the not equal to sign in alternative hypothesis. So from the alternative hypothesis we can see that this is containing the not equal to sign. That means this is a two directional alternative hypothesis and the test will be two-tailed test. Okay. Now step 2 is finding out the value of the test statistic. Okay. The formula for test statistic is given by t equal to x1 bar minus x2 bar divided by s square root of 1 by n1 plus 1 by n2. Okay. So x1 bar, x2 bar are given, these are sample means. N1, N2 are also given, these are sample sizes 10, 10. Okay. S, where is S? We have to find out this value of S. This S is the pooled standard deviation. Okay. So we are given two standard deviations and from these two we are finding out this pooled standard deviation. So the formula for S is N1 minus 1 S1 square plus N2 minus 1 S2 square under square root divided by N1 plus N2 minus 2. So from the given observation we put the values of N1, S1 etc. So 10 minus 1 multiplied by 4.9 square, 10 minus 1 multiplied by 4.64 square divided by 10 plus 10 minus 2, and the value comes out to be 4.772. Now we put all the value in the test statistic formula. So sample mean for first sample is 10, that is for brand A, and for brand B it is 18.66. We put down the value of the pool standard deviation we have calculated, 4.772, 1 by n1, 1 by 10 plus 1 by 10. Okay. So 1 by 10 plus 1 by 10. So final value comes out to be minus 4.06, negative 4.06. This is the value of the test statistic. Now we go to the decision rule of the problem. Okay. So what was our level of significance in the question? Level of significance was alpha equal to 0.05 and the test is two-tailed test because the alternative hypothesis was containing not equal to sign. So for two-tailed test what we do, we divide alpha into two parts, alpha by 2, 0.025. What does that mean? That means the critical region will be at the two tail of the t distribution. Okay, and this will be negative minus t 0.025 and positive 0.025. That means these two are critical region, they have the area 0.025, 0.0. Then we calculate the degrees of freedom. In T distribution, the degrees of freedom is very much important to find out the critical value. Okay, degrees of freedom, the formula for 2 sample T test is given by n1 plus n2 minus 2, that is 10 plus 10 minus 2, which comes out to be 18. Okay, now from critical value table, for alpha equal to 0.05 or alpha by 2 equal to 0.025, we find and df 18, we find out the critical value to be plus minus 2.101. Why it is plus minus? Because in the left side it is negative 2.101 and in the right side it will be positive 2.101. Okay, so with this side and this side are critical region, that is, if the value of the test statistic falls either in the right side of 2.101 or in the left side of 101, we reject the null hypothesis. So our decision rule is reject H naught if modulus of T greater than 2.101. Step 4 is the decision. So what was our value of test statistic? T equal to negative 4.06, that is modulus of T is equal to 4.06 and it is greater than 2.101. Therefore, our decision is to reject the null hypothesis because the test statistic value falls in the critical region. Final step is conclusion. Okay, so we are rejecting the null hypothesis. That means we are rejecting the statement that mu1 equal to mu2. So there is the final conclusion will be there is sufficient evidence to conclude that two brands of fertilizers differ significantly. Now we go to p-value approach. Okay, for p-value approach, the step 1 and step 2 are same, that is formulating the null and alternative hypothesis and then finding out the value of the test statistic, which is negative 4.06. Then step 3 will be calculation of p-value. Step 3, calculation of p-value. We know that the test is two-tailed. That means p-value will also be at the both tail of the T distribution. Now the value of test statistic is negative 4.06. So p-value will be left side of negative 4.06 and the right side of positive 4.06. So what is the formula for p-value? The formula for p-value is probability modulus of T greater than 4.06. Okay, for T distribution, the calculation of p-value is not possible manually or with the help of T distribution table. We can find out the exact value p-value using some software. I am using Excel formula. How we calculate from Excel? It is given by put a equal sign in any of the cell, then T distribution dot two tail, because this is a two-tail test, then write down the value of the test statistic, that is 4.06. we put the positive value because it is at the both tail, so we can put any of them, and the degrees of freedom. Okay, so this comes out to be the exact p-value 0.000735. So p-value is 0.000735, or we can put it like this, 0.0007. Now we go to decision. Now in p-value approach, how we come to the decision? If p-value is less than the significance level, that is 0.05 in our case, then we reject the null hypothesis. Okay, so So we can clearly see that p value is 0.0007, which is very much less than 0.05. So we reject the null hypothesis. Step 5 is the conclusion. There is sufficient evidence to conclude that two brands of fertilizer significantly differ. So this is t-test for two means and for two-tail test. Next we go to t-test for two means for one-tail test. Now we go to the second part of the problem. At 5% level of significance, do the data provide sufficient evidence to conclude that mean yield of brand A is less than that of brand B? Okay. So first step is formulation of null and alternative hypothesis. Okay. So as we know that the null hypothesis is the hypothesis of no difference, we state that mu1 equal to mu2. The alternative hypothesis comes from the question here. Mean yield of brand A is less than that of brand B. Okay. So mu1 is for brand A, so we say that mu1 is less than mu2, and this is the alternative hypothesis. Now the alternative hypothesis is containing this less than sign. So this is called left directional alternative hypothesis, and the test is left tail test. Okay. Now second step, the calculation of test statistic. So test statistic is calculation is same as earlier. So putting the values in the test statistic formula, we find that the value is negative 4.06. Okay, and calculation of S is also shown before the earlier part of the problem. Okay, then we go to the third step. Step 3 is the decision rule. Okay, so at alpha equal to 0.05, we have to find out the critical value. Degrees of freedom is calculated earlier, that was 18. Okay, and this is a left tail test because the alternative hypothesis is left directional. So the critical region will be at the left side of the graph. Okay, so this is our 0.05, the area. Okay, and we have to find out negative t.05. Okay, from t table for alpha equal to 0.05 and degrees of freedom 18, we find the critical value of t to be negative 1.734. Okay, this is negative value. We take the value as negative because it is a left tail test, and this critical value of t lies in the left side of 0, because the t distribution is symmetrical about 0. So whatever in the left side will be negative value, whatever in the right side will be the positive value. Okay, now the decision rule. So we reject the null hypothesis if our test statistic is in the critical region. Now where is the critical region? Critical region will be this side. Okay, and this side will be acceptance region. So this is critical region, this is acceptance region. So reject H naught if the calculated value of t is less than negative 1.734. Now step 4, decision. Okay, so we can see that t equal to negative 4.06, our calculated value of the test statistic, and clearly it is less than negative 1.734. So that means the calculated value of test statistics lies somewhere here, negative 4.06. So it is lying in the critical region. Therefore our decision is to reject the null hypothesis. Okay, then we go to the final step, that is conclusion. Okay, so conclusion is how we draw the conclusion. we reject the null hypothesis. What was null hypothesis? That both the means are equal. That means we have enough evidence to support the alternative hypothesis. That means brand A has lesser means than brand B. Okay. So our conclusion is there is sufficient evidence to conclude that mean yield of brand A is less than that of brand B. Okay. So we are done. Now we will do the same problem with the help of p-value method. In p-value method, the first two steps are same. That is, we formulate the null and alternative hypothesis, we find the value of test statistic. Now we go to step 3, that is calculation of p-value. So calculation of p-value, since this is a left tail test, the p-value will be at the left side of the t distribution. Okay, so the p-value lies here, and p-value is calculated on the basis of the calculated value of test statistic. So what the area towards the left of negative 4.06 is our p-value. So the formula for p-value will be probability that t less than negative 4.06. Okay. Now we find out the value of this probability with the help of Excel. As I have told you, for t distribution the calculation is not possible manually, we need some software. Okay. So in the Excel, what we do, in any of the cell put equal sign and then t distribution. Okay. This is left tail, so we shall not choose the two tail and right tail, we shall only choose the t distribution. Okay. And then put the value of test statistic, that is negative 4.06, and the degrees of freedom, that is 18. Okay. This will give us the p-value. Put enter. Okay. Sorry, one more thing, this cumulative value. So since this will give the left side area, so you have to put that cumulative is true and then put enter. So this is our p-value. Okay. So what do we get? 0.000367. 0.000367. So let us write down as 0.0004. Okay. Now find the next step is decision. So in p-value approach, how we come to decision? We compare the p-value with the level of significance. Okay. Our level of significance here alpha equal to 0.05, and we can clearly see that p-value is less than 0.05, and whatever be the test, whether it is left tail, right tail or two tail, we compare the p-value with significance level, and if it is less than the significance level, we reject the null hypothesis. Then the last step is conclusion. So we conclude that there is sufficient evidence to conclude that mean yield of brand A is less than that of brand B. Okay. So this is our hypothesis testing. Now I shall show you how to get the critical values from T table. Okay. For the first part of the problem, we had our significance level as alpha equal to 0.05 and degrees of freedom 80. Okay. So here we can choose the two tail alpha equal to 0.05. Okay. And the degrees of freedom 18. Okay. So choose the row for degrees of freedom 18 and column for two tail alpha equal to 0.05. Okay. The intersecting cell is 2.101. Okay. That is our critical value of T for alpha equal to 0.05, degrees of freedom 18, two tail test. Okay. And for one tail test, our alpha was 0.05, so we shall choose alpha from here one tail 0.05 and degrees of freedom 18, and the intersecting cell is 1.734. This is positive value 1.734, but since our test was left tail test, we will make it negative. So our critical value will be negative 1.734. If the test is right tail, then it will be positive 1.734. This way we find out the critical value of T.